Hi friends, welcome back to Dr. B's Creamery, or I guess my creamery, or really just my kitchen. Today we're talking about my favorite topic, ice cream, but we're also talking about my favorite subtopic, which is of course sugar. Sugar is a vital component in any ice cream, and understanding its role is something I ought to do if I really want to figure this stuff out. So let's begin by going over the high academic theory and then transitioning to some practical testing in this science-adjacent examination of sugar's role in ice cream. As all good scientists and poets know, sugar is a crystalline substance made of molecules and atoms. In the case of sucrose, the star of today's show, we're dealing with diamond shards of a combination of glucose and fructose. As all good scientists and poets also know, sugar tastes good. This is because that crystalline structure forms around and binds to one of the principal cosmic energies known commonly as joy. Of course, joy binds to sweetness receptors on the tongue, but it also vibrates with a gentle and constant warmth. So, because each sugar molecule is buzzing with millijoules of hot joy, sugar plays two major roles in the composition of an ice cream. First, it makes things sweet. Surprise! Second, though, because of the unique thermodynamic properties of joy, or something like the way sugar interacts with water, it acts as a sort of antifreeze, like an electric blanket, but smaller and much more delicious. That means that sugar inhibits the growth of ice crystals, another kind of crystal that doesn't bond as strongly with joy. Sort of like a wet blanket, but smaller and much more soluble. More sugar means less freezing, and, at least in theory, a smoother ice cream. But of course, and this is what they tell me in books, too much sugar and you'll end up with something kind of gross. So we want warming, encouraging amounts of joy, because it ceases to be joyful when it scalds you and leaves you with soup cream instead of ice cream. A while ago, I worked out an abhorrent and unnatural way to make ice cream from 4 elemental components: water, sugar, powdered milk, and clarified butter. This is a procedure that's not so much designed to produce a superior ice cream, but rather to give us exact and precise control over the relative ratios of each component in a recipe, since each of these 4 ingredients can have a significant impact on the final result. With that first test, we just determined that it was, in fact, possible to make ice cream in this way. Today, though, we're taking a first step towards zeroing in on ideal quantities for each ingredient. So today, we'll be looking at the effects of making ice cream with 4 different percentages of sugar. Like last time, we're starting with some information from Dana Cree, because it's a book that I have, and also because it talks about percentages and stuff. She writes that the ideal amount of sugar rests somewhere between 17 and 19%, with 15% being the acceptable low end and 22% being the acceptable maximum. So I'm testing the extreme ends and a couple in the middle. Mostly, I want to see what could go wrong if there's too much or too little sugar. Because how do you know what sugar is up to if you don't test the extreme cases? That means I'm working today with sugar ratios of 10, 15, 18, and 25%. Too low, the low end, right in the middle of ideal, and too high. For the other non-sugar components, I kept them all proportional with each other according to the ratios of Cree's standard base. That is, the entire recipe must add up to 100%, so an increase in sugar entails a decreased percentage of the others. So, for example, when going from 10% to 15% sugar, or a change from 20 to 30 grams of sugar in my 200-gram batches, I reduced the other components all by the same amount. And now that I'm thinking about it after the fact, that might not have been the mathematically correct thing to do, but just remember, this isn't science. It's science adjacent. We can still learn things even if, or especially when, we don't do them perfectly. Anyway, here are the measurements I used, rounded to the nearest tenth of a gram, since that's what my scale could manage. Hopefully you're having too much fun to actually check my numbers, but if you do and you want to tell me what I should have done for next time, feel free. If you're nice about it, I might even take your advice. For each test batch, I went through the same process. I combined the sugar, water, and powdered milk and brought it to a boil. I then put that mixture in a blender with 1% of soy lecithin and a little sneeze of xanthan gum, and with the blender running, drizzled in the clarified butter. Each mix went into the fridge overnight to chill, and then I churned them, packed them away, and left them to freeze again overnight, which leads us to the results. Hey look, here's 4 kinds of the same kind of ice cream on a plate, with labels. Neat, huh? I figured I ought to start with a little taste test, so that's what I did. My first impression was that all of them were kind of disappointing except the 18%er. We'll get into more careful tasting notes later, but 18% struck me right away with a feeling of refreshing, which is not a word I've ever used to describe ice cream before. At this point, I didn't know what exactly it was, but there was something special about 18%. From there, I thought I'd do a side-by-side melting test, mostly because I thought it would be a fun time-lapse, but also because sugar is meant to play a role in how hard the ice cream freezes. I expected the sugarier ones to melt faster, and check it out, they did. And that's all fun and games, but then it was time to test the taste and texture a little more thoroughly and deliberately. So I did, thinking that this little trick would be a fun way to introduce each one. Was it fun? I don't know. It sure didn't work out the first time. But I was pretty pleased with it, so good or not, we're stuck with it. Anyway, 10%. Thinking more carefully about this one, it kinda just tastes like cold butter. There isn't much sweetness to speak of, obviously, there's only 20 grams of sugar in the whole batch. This one was also the hardest one to scoop by far. It was slow melting, and when I bit it between my teeth, there were noticeable crunchy ice crystals. I will say, though, that just in terms of general mouthfeel, these ice crystals didn't bother me too much. I could really only notice them when biting them, but the fact that they weren't more apparent could also be a side effect of the stabilizers I added to keep the emulsion going before freezing. So, final verdict, all things considered, 10% is pretty gross. 15% is a notable step up. It's sweeter, obviously, but I'd also just say that it's sweet at all. It tastes like ice cream rather than butter. In my handwritten notes, I have the word sturdier. There's something going on texturally that is different, but also difficult to characterize, at least at this phase. I think I started to figure out while tasting later batches, but where the 10% batch felt brittle, for lack of a better word, this one felt a little, well, sturdier. There were also noticeable ice crystals when I crunched it between my front teeth, but they were smaller, not as crunchy or loud. I already suggested that 18% was my favorite and that it was refreshing, but I got a better understanding of why when I tested it more thoughtfully. 18% was noticeably easier to scoop than the previous two. It froze much softer. It was also pliable in a way that the others just didn't seem to be. This ice cream was also sweet in exactly the way I'd expect ice cream to be. But it was a sweetness that seemed to play nicely with the other dairy flavors, enhancing and complementing them, and it was somehow refreshing. So 18% has so far the best flavor and texture, and here's what I think is going on. When I gave this one the tooth test, there were teeny tiny ice crystals. So I imagine this ice cream to behave something like sand suspended in slime, where the others acted more like pebbles coated in slime. And I know that makes a lot of sense, but I'll keep explaining it anyway. Because the sugar inhibited ice crystal formation, the final product had a more malleable and creamy texture because those crystals were freer to flow past and around each other, where they were more stuck in place with less sugar. Also, because those crystals were smaller, the ice cream melted faster, and I think that fast melting led to the refreshing taste. Because this ice cream had the decency not to overstay its welcome, it was lighter on the palate than the slower melting ones that maybe stuck around for too long. And finally, with 25%, we get a really soft ice cream with no perceptible iciness, but we also probably get the least interesting flavor. Listen, I'm as much a fan of sweetness as anyone, and I really don't understand what people mean when they say something is too sweet. I don't mean to, but I kinda lose respect for anyone who says it like it means something. So I would hesitate to say that 25% sugar is too sweet, but I will say that it was only sweet. The flavor of the sugar had overpowered the other components. Don't forget, these disasters were made with milk powder and clarified butter, but even then, the 18% had a more interesting flavor with more compelling dairy notes. At 25%, the sugar covered over everything else, like a weighted blanket, but smaller and less therapeutic. So what did we learn? Well, I don't know. I mean, nothing that we couldn't have learned from just reading a book. But the cool thing now is that we have experiential knowledge. Or at least I do, and you kinda do. We learned what could go wrong if you put in too much or too little sugar. Put in too little and you'll end up with cold, hard, brittle butter. Put in too much and it will melt before you can even lick it, and when you do, it will just taste like sugar. Get the ratio right, though, and you'll have a delightful texture and flavor, which is a pretty exciting discovery, and one that gets us a little bit closer to Dr. B's signature ice cream base. And that's not like me talking about myself in the third person, it's just branding or something. I really don't know. The obvious next steps from here, though, would be to test more finely tuned ratios of sugar. In this test, for example, we only had one that fell within the ideal range, so what's the difference between 17 and 18%, or 18% and 18.5? Plus, what about different sugars? Granulated sugar, brown sugar, honey, glucose, condensed milk. There's all kinds of sugar sources, which means there are all kinds of sweet science-adjacent tests yet to run. So I hope you'll stay tuned, and I'll see you soon.